Good afternoon, good day from wherever you join us in the world. My name is Gladys Ibrahim, and myself and my partner, Johnny Udwak, both from Nigeria, we will be arguing in support of the debate which says, should governments prioritize funding genetic research to develop climate resilient ecosystems over renewable energy and other climate change mitigation strategies? In introduction, insanity is doing the same thing over and over again and expecting different results. For decades, global efforts have focused on reducing carbon emissions through renewable energy and mitigation strategies. Yet, despite billions of dollars in investments, climate disasters are worsening, food security is threatened, and entire ecosystems are collapsing. Governments must invest where the greatest impact lies, in the genetic blueprint of life itself. We'll start by defining a few key terms. First, what is a climate resilient ecosystem? This is an ecosystem that has the ability to anticipate, absorb, adapt to, and recover from the adverse effects of climate change while maintaining its essential functions, structure, and biodiversity. Genetic research, in the context of these debates, refers to genetic modifications and biotechnological innovations aimed at creating species that can better withstand climate change impacts. In essence, they are modifications that enable adaptability. Renewable energy, on the other hand, is energy sourced from naturally replenishing resources, which plays a critical role in reducing greenhouse gas emissions. Now, what is the core focus of this debate? This debate hinges on whether adaptation strategies, that is, genetic research for climate resilient ecosystems, should be prioritized over mitigation strategies, that is, renewable energy and emission reduction efforts. Both approaches are essential, but the question is, which should receive greater government funding and policy attention based on one, urgency, two, cost effectiveness, and three, long-term impacts. We start with urgency. Climate change has caused and is still causing a lot of damage. Droughts are becoming longer and more severe. The 2022 Horn of Africa drought was one of the worst on record, leaving over 36 million people facing hunger due to failed crops, as reported by the UN Food and Agriculture Organization 2023. Warmer air holds more moisture, leading to heavier and more erratic rainfalls, which results in devastating floods. For example, the Pakistan floods of 2022 submerged one-third of the country, affecting over 33 million people and causing $30 billion in damages, according to the World Bank 2023. Warmer ocean temperatures fuel stronger tropical storms, causing massive destruction to ecosystems and human infrastructure. The Hurricane Ian in 2022 caused over $113 billion in damages in the US, making it one of the costliest storms in history. Adaptation is critical in achieving a quicker response. For the sake of our survival, we need to act fast. Some genetic solutions we have seen include the drought-resistant maize in Africa, which has already increased yields by 20 to 30% in regions experiencing extreme drought. The flood-resistant rice developed by the International Rice Research Institute can survive 10 to 15 days underwater, securing food for millions. Coastal mangroves and salt-tolerant crops can act as natural barriers, reducing storm damage and providing food security in affected regions. Genetic research offers a direct response to climate threats rather than just a preventative measure.
Climate disasters have led to severe annual losses, and renewable energy strategies need high costs of installation and constant maintenance. On the other hand, genetic-based solutions are self-sustaining once established. Genetic solutions are indeed affordable. Developing countries may find it difficult to build renewable energy infrastructure, but can implement climate-resilient crops with ease. Note that the cost of running genetic analysis have dropped drastically due to availability of reagents and the required equipment. Now, looking at the future perspective, of genetic solutions. We have this to say: genetic research has a promising long-term impact. It develops the ecosystem. In line with this, Stock Institute has come up with development of enhanced plant root structures to store high amounts of carbon in the soil. This enhances the reduction of carbon dioxide in the atmosphere. Now let's move to the rebuttal section. First, the opponent team mentioned that renewable energy is ready for deployment, but genetic research takes time. Well, on this, I'll say that the solution is already on ground. Examples include drought-resistant crops, as well as flood-tolerant rice. These have offered solutions to food security as well as biodiversity. They are also scalable at minimum cost. Secondly, the opponent's team referred to economic benefits from renewable energy through job creation. But I'll have this to say that genetic research also offers economic benefits. It creates biotechnology job, okay, for people in that field. And this same genetic research also minimizes economic losses that arise from crop failure and environmental disasters. Thirdly, the opponent team mentioned that renewables benefit all, while genetic research favor the wealthy. Well, I want us to take note that genetic research targets low-income countries. So these countries are not at a disadvantage in any way. Also, there are modalities that have been put in place to prevent corporate monopoly. Okay, back to Gladys.
Also, our opponents claim that renewables are cost efficient while genetic research is expensive and uncertain. The International Energy Agency begs to differ. They estimate that transitioning to 100% renewable energy requires $4.5 trillion globally by 2050, whereas genetic improvements have provided $120 billion in economic benefits over 20 years with relatively low investment. Developing countries may struggle to implement large-scale renewable projects, but genetic research offers a more feasible way to build climate resilience. Lastly, our opponents claim that renewables eliminate fossil fuels, solving the root cause, while genetic research only helps ecosystems adapt. The Intergovernmental Panel on Climate Change 2023 reports that even if emissions were cut to net zero today, the effects of past emissions will persist for centuries. Genetic research provides long-term natural resilience to damages that are already here to stay. In addition, renewable energy has significant environmental downsides. Solar panels require large land areas and mining of rare earth metals, leading to deforestation and pollution. Wind farms impact bird and bat populations and require high maintenance. Hydropower disrupts freshwater ecosystems and displaces communities. Genetic research does not create the same level of environmental destruction and can provide solutions with minimal ecological impact. In conclusion, throughout these debates, we heard arguments about the importance of renewable energy and mitigation efforts, but let us not ignore the reality staring us in the face. Even if the world stopped burning fossil fuels today, climate change will not stop. Genetic research is not science fiction. It is already saving lives. Around the world, scientists are unlocking nature's own ability to fight back. Governments have a choice to continue focusing solely on slowing down climate change or investing in solutions that will help us survive it. Nature has always adapted, but it takes centuries. We do not have centuries. Genetic research gives us the power to accelerate adaptation, to secure our food, our biodiversity, and our very existence. Let us choose survival. Thank you very much. These are our references.